guys, here is the video for Module 5. Sorry, I have to do a restart here. This is the last module for your fall final exam. All right, for number 1, we're graphing and writing the equation of parabolas in standard form given this information. So the vertex of the first one is at -4, +3. My focus is at -2, +3. And I know the focus is equidistant from the vertex as the directrix. So the directrix is going to be -2 in the other direction. If this distance here is 4, then I know I'm going to go 4 in this way and 4 on this side. So up 4, 1, 2, 3, 4. Down 4 will give us 2 good points for this sideways parabola. Since it's a sideways parabola, I know it's an x equals. It's going to be 1 over my focal width, which is 4 + 4, which is 8. It's going to be y minus, the opposite of the vertex, so y minus 3 squared. And then same for the x, which is -4. All right, number 2, my focus this time is at 4, -2. And my directrix is at -8. And then what's halfway between the focus and the directrix is the vertex. And so my vertex is at 4, -5. Now the distance from the directrix to the focus is 6. So I know my focal width is going to be 6 to the right and 6 to the left for a total of 12. And since we're curving around and touching that focus, this is an upward opening parabola. Since it's upward, we know it's a y equals. Since it's positive, my focal width is going to be positive. And my focal width for this time is 12. 6 + 6, which is 12. And then minus x minus 4 for my vertex squared, and then -5. All right, graph the following problems given the equation in vertex form. I actually like moving the 2 over and making it look more like what we're used to. And since this one is a x squared anyway, we know how to find our vertex from this guy. So the vertex would be -3, 2. Axis of symmetry goes through the x value, so it's x is equal to -3. And let's graph that. So we've got a point at -3, +2, that's our vertex. We know our focal width is going to be 4 and it's opening down. So if the focal width is 4, we know we're going to go down 2 to get to our focus and up 2 to get to our directrix. And then, just kidding. If our focal width is 4, let's start again. Here's my vertex. If my focal width is 4, I know half of that is going to be how much. So, sorry, I can't speak. If my focal width is 4, I know it's going to be 4 across, right? Well, that means the distance between my focus, I don't know why I can't speak today, between my focus and the parabola would be 2. And half of that distance is what it is from the focus to the vertex, and half of that is from the vertex to the directrix. Oh, I think I got it out there. So let's go through that step process again. So I put my vertex on, my focal width is 4, which means half of that is going to go on one side, half on the other side. So the distance from the axis of symmetry to that point is 2, and I take half of that. Half of that would be going down 1 for the focus and up 1 for the directrix. And notice if we go out 2 and out 2, that's how we get these points. And we get a focal width of 4, which we find here. All right, so our focus is located at -3, 1. Our directrix would be y is equal to 3. And our focal width, like we said from the very beginning, is 4. All right, number 4. Again, I'm going to scoot this guy over to find my vertex. X is equal to 1/16. y plus 1 squared minus 4. My vertex then is going to be the same for the x, opposite for the y because it's the one inside the parentheses this time. Axis of symmetry is this time going through y, so it's y equals -1. And let's graph that. So I've got a vertex at -4, -1. My focal width is 16. So that means we're going to go to the right 8 and to the left 8. And then half of this is how far away we are going to the vertex and the directrix. So let's see, this is an x equals y squared. So our focus, oh, look at this backwards. We should be going this way 8 and this way 8 to get to our focal width. And if we do half of that, is how far from my vertex I'm going to put my focus. Since it's positive, I know my focus is going to be to the right, so that'll open right. So I'm going to do half of 8, which is 4, which would put me right here. And the other half of 8 would put me back here at -8. So -4 minus 4 would be -8. All right. So now if we look at it, the distance from the directrix to the focus is 8. I'm going to go down 8 to get to one point, up 8 to get to the other point, and here's my parabola. Notice it gives me the 16 total across that I need for my focal width up here. So the focus for this one is at 0, -1. My directrix is down here at y equals -8. And the focal width, like we said, was 16. All right, 5 and 6 are kind of challenging. I'm going to do all of them. I'm going to just put up with the focal width and the focus art. They're really ugly for these 2 problems, so I'm not sure why they would want you to calculate them. Trust me, and that it's not going to be nearly this hard on your test. But in order to put it in vertex form, first we've got to complete the square. Since I see the x is squared, I know it's going to be a y equals, which means I'm going to move everything else over. So -3x squared becomes positive when I move it over, plus 6x, and then -4. But I need to complete the square to get into vertex form. I'm going to pull out the 3, I get x squared plus 2x, save room to complete the square, -4. All right, we're going to take the middle term divided by 2. 2 divided by 2 is 1. 1 squared is 1. 1 times 3 is what we added. So we added 3, we need to subtract 3. So in vertex form, I got 3 times x plus 1 would be my perfect square here. 1 times 1 is 1. 1 plus 1 is 2. And then -4 minus 3 is -7. Because 3 is positive, we're opening up. My vertex is going to be opposite of the x because it's in the parentheses. Same for the y. Focal width and focus. So this is where it gets really kind of funky. But your focal width is 1/6. And your focus is at -1, -83/12. I'm not even about to take us there. Don't worry about it being that hard. If you can look at a problem like this and tell me the focal width is 16, you'll be fine for this test. All right, number 6. If we want to put this in standard vertex form, in standard form, we've got to complete the square again. This time it's the y squared that's going to get flipped over, and so I'm going to leave the 4x over here. So I got -2y squared plus 12y that's already over there, and then moving the 6 over, I get -6. I'm going to complete the square. In order to do that, I'm going to pull out the -2, which leaves me with y squared and then -6y. All right, completing the square, take that middle term. -6 divided by 2 is -3. -3 squared is 9. But I'm not adding 9, I'm adding 9 times -2, which is -18. So I'm going to add positive 18 on the outside. So 4x is equal to -2 times y minus 3 squared. That's what this guy is. -3 times -3 is positive 9. -3 minus 3 is -6. And then 18 minus 6 is positive 12. Last step, I'm going to get this x by itself, so I'm going to divide by 4 for each of these terms. So x is equal to -1/2 y minus 3 squared plus 3. Since it's y squared, we know it's opening left or right. Since it's negative, I know it's going to the left. The vertex is going to be the same for the x this time, opposite of the y because it's the one in the parentheses. And the focal width for this one is 1/4. Focus is 5/2, 3. Again, do not stress that. You're going to be just fine. All right, number 7. I am actually going to pause the video here and start number 7 on the next video because we're moving on to systems.
Can you pause it at the last one you did so I can copy it?